Okay, so let us begin today's session. So actually now I will go over the uh, summary of the previous week's content. Hmm. So in the previous week, sir basically taught us about input output operators and the STL library. So so as we know that the C programming language provides many standard library functions for input and output, and all of these functions are in the stdio header. So this is about C. Okay, all these things are about C. So you have various kinds of functions like file open and close, formatted input output, character input output, line block, file positioning, and uh, system. Wait. So all these things you have. So these are some definitions of a file and a stream. Okay, you can go over the slides. So I will not go in detail. So when you in C, when you open a file, you have to specify the mode in which you open. So these are the various modes available. There are 6 modes. Okay, so you can go over it like what is allowed and what is not allowed. So the basic way of you handling C files in C is that first we have to open the file. So for that we can use this fopen function, and it returns a file object. A file is a struct. Okay, so in C we don't have any objects or such things. So a file is a struct which contains information about the open file. So the file object denotes a C stream and keeps the state during I/O. So to open the file, we have to specify the file name, and we have to specify the mode. So mode means that whether it's read mode or write mode or append mode, like that. And after successful opening, we can read the file or write to the file using the read or write functions. And at the end, we must close the file. Okay, so closing is very important because it flushes unwritten buffered data and discards unread buffered data. So it is very important to uh, do this. So here you can see a simple example of file opening and closing. So first we define a file pointer. Okay, and then we have to use this fopen function with the name of fopen function with the name of the file and the mode. So in this case, the user has opened it in read mode. So this function will return a file pointer, and we must check whether it has successfully opened or not. If it is successfully opened, it will have some value, or else it will have a null. So the file pointer will be null. So in this if line, that is also being checked. Okay, and then after success, this is just for opening. And after successful opening, here you can perform IO in this section. And after that, you have to close it. So when you call the fclose function with the file pointer, and on if it closes successfully, it should return EOF. EOF is a constant value, which is like a flag. It is a constant value. If the file is closed successfully, it will return this. Next, there is a section on formatted IO. So formatted IO basically means that suppose we have to suppose we have a int variable, uh, which has a, so as you know, a int variable is a normally it is a 32-bit number. Okay, so if we directly print it to the output, so then if we directly print it to the output, then this 32 bits means it is 4 bytes, right? Wait a minute. It is 4 bytes. So then if it prints the 4 bytes directly to the output, then you will not get basically a meaningful output. You will get some garbage looking output. So what happens is that this integer is taken and it is converted to a human readable form, and then it is printed. So that is the function of formatted IO. So it takes the raw value such as a integer or a float, and it converts it to a readable format. Similarly, if you think of the double data type, it has so double has 64 bits, 64 bits, so 8 bytes. Okay, and you know that floats are stored in that IEEE 754 format. So if you directly print the bytes, you will get garbage looking value. It has to be converted to a human readable form. So the basic way is this, that to print using the for in formatted way, we use the functions with the f. So all of the formatted functions will have a f at the end. So printf, f printf, s printf, and then the format is that first we specify a format string and then we specify arguments, and these functions can take a variable number of arguments. So these are the variants. We can either print to the console, or we can print to a file, or we can print to a string. Similarly, all of the same functions are there for the read. And what is this format string? The format string specifies that so basically the format string specifies in which format to print all these values. Okay, so like if you are printing a double value, so how many decimal points should be there and all. Okay. Hmm. So all the details is there. Okay. These are all the flags you can specify in the format string. Okay, like left justify, the sign, or zero padding, and then the precision. Okay, so how many decimal points you have to give, or the minimum or maximum width. Okay, and then the data type, like what you are trying to print. Okay, how should it be interpreted, like is it a double or a int or a float, and there are some conversion codes here. Okay, so all of these things that used to specify the format string. So this is an example where all the very like the effect of these various format strings is shown. Again, this is like there is nothing to explain here. So this is like you have to memorize all these, the meaning of all these codes and flags. Next we come to unformatted IO. So unformatted IO will directly read or write bytes. So you basically have these you have functions like get char, put char, and get c, put c, unget c. So all these functions. So here is an example where you copy a file to another file. Okay, no, wait. Okay, so it's not copying, it's creating a text file. Okay, so in this function you open the file, and in this function you close the file. And here what you do is you basically take a string from stdin, so from the console, and you write it to the file. Okay, so you use get chart to get the character from the console, and then you use fputc to write it to the file, the exact same byte. Okay, you write the exact byte to the file without any formatting. So this is there. Okay, next we have file positioning. So like in a file we might want to start reading from the middle, or we want, suppose we have read till here, and we want to go back, we again want to read it from the beginning. So in that scenario, file positioning, or you can also call it seeking, that is important. So to go to any arbitrary position in the file, we use this fseek function. Okay, so now I will go over the next module. So in the previous slide we discussed C input output, and this is about C++. So in C++, the main difference is that instead of these file structures and all these format strings and all, we try to use types type safe approach, and also object oriented approach. So, and also the another feature is extensibility. So one drawback of the C style approach is that we cannot easily extend it to uh, user defined data types. So that is also supported in C++. So in C++ we have a concept called streams. So it replaces all these input and output functions. So streams are of two types basically. One is the input stream and one is the output stream. So an input stream, it is a stream that flows from an input device to the main memory. So you can think that a stream is something that takes, it is used to, input stream is something that takes input from a keyboard or a file or a network connection, and it gives it to some local variable. So here there will be some variable, and here there will be the stream. And the opposite thing happens for the output stream. So for the output stream, you have the stream, and the local variable is put into the output stream, such as screen or a printer or network connection, or it could also be a file or a database, like that. So this is an example of the various flags you can set to the cout function. Okay, so this is not the flags, but it shows an example that what happens when you pass variables of different data types to the cout stream. And we can also print user defined data types. As you saw in previous uh, previous modules, we have to, like, in the user defined data type, we have to define a function. We have to overload this we have to override this output stream operator. Then we can print the user defined data type in the same manner. Okay, so cout and then c1 c2, where c1 c2 are utilities. Then this is the input stream. So now we come to this file input output. Okay, so in file input output, uh, we, like in C, we saw that we use this fopen and fclose functions and they return a file star pointer. But in C++, we define input and output stream, and we call dot open on the input and output streams. Okay, so and then we can read from the file in the similar manner. So here there is an example. So it is writing to a output file. You can see that we first create a output file stream and then we call stream.open, and then we can write in the same manner as we write to console, and then we write myfile.close. And similarly for input, first we define an input stream, and then we define an input stream with the file name. Okay, and then if the file is open, we use getLine to read the file line by line, and then we call myfile.close to close the file. So why do we call it type safe IO? Because it is type safe, because you will see that in cout and cin we don't have to specify the type explicitly, or we don't have to specify the type two times. If we pass an integer to cout, then the C++ then C++ it automatically deduces the type from the data type of X. Okay, whereas in C we have to specify the type explicitly, even though we know that we are printing an integer and we are passing an integer, we still had to specify that this was indeed an integer. Okay, so basically this is an integer and we have to specify again that this is an integer. So if there is a type mismatch, then there could be problems here. So in C++, that problem is solved because the type is deduced from the data type of the variable. So one more thing is that there is something called stream manipulators in C++, which can be used to set. It can be like all the streams, they have some settings. Okay, so you can change the settings of the stream, such as you can set the field width or the precision, or you can set or unset the format flags, and you can set the fill character, and you can flush the stream, and you can insert a new line character and flush the stream. So all these things you can do. For example, like say this is a precision and set precision uh, manipulators. Okay, they can change the precision or of the stream. So it means how many decimal places or how many significant figures will the stream print. So there are lots of manipulators. You can go over this. Next, sir discussed about the STL library. So STL library is a very important library because it is a large collection of general algorithms and data structures. Okay, so it is a large collection of general algorithms and data structures which can be used for a large variety of problems. So here is an example that the difference between C and C++ standard library. So here we use stdout, stdin, printf, scanf and all. And but for C++ we use stdcout, stdcin, and all of these functions are in the standard library. So we can use using namespace std to get rid of the unwanted std. Okay. So see, you can see in these slides basically, um, as you know, vector is a dynamically sized array. Okay, vector is a dynamically sized array. But this dynamically sized array, it is a generic data structure because it does not depend on the data type of the one minute. Hello. Okay. So this is a dynamic data structure because it does not depend on the data type of the elements being stored. Okay. So there are many such data structures which are part of this STL standard template library, such as map or pair, or you can say queue. Wait a minute. Hello.
Yes, sir.
Yes, yes, I'm sharing. Okay, so there are many generic and useful data structures that are part of STL, such as map, pair, or queue, or there are algorithms also like sorting, okay, or binary search. So all these data structures are generic in the sense that they are not meant for any one data type. Okay, they can be applied to any data type, even user defined data types. So for user defined data types, you might have to specify some function, such as for sorting and binary search, you have to specify some functions, but otherwise they can be used. So this was not possible in C, because in C you would have to specify the data type for every function that you do use. So all this is there. Now let me start the exercises. Okay. Okay, so this is the first question. Please solve on your own.
Sir, I think the correct option is D because 67 is not put inside. Uh,
No, yeah, not put inside what?
sir, like we have to use for defining character. What we say this double inverted commas. I don't know the correct terminology.
Oh, okay, okay. Uh, no, no, this is it will work. So that line is fine. There won't be a error.
Okay.
So one thing that you must remember is that the characters and integers, they uh, like a character is a one byte integer only. Just the name is different. So what will in this case, since there is no inverted commas, what will happen is that the one byte that a character has, it will be set to 67.
Okay, sir.
Okay, so in this question, so a is set to 0x67. So that means that okay, so 8 a is set to 0x67. So in the in C or C++, okay, uh, before a number, if 0x is present, then the rest of the number is interpreted as a hexadecimal number. So 0x067 will be interpreted as base 16 number. So this will be 6 into 16 plus 7. This will be 96 plus 7, which is 103. Okay, and the second variable is b. B is set as 067. So if a number has a leading 0, like a 0 in the beginning, then it will be interpreted as a octal number, which means a base 8 number. So this will be 6 into 8 plus 7. So this will be 48 plus 7, which is 55. And for the C variable, there is no leading flag. Okay, there is no 0x or 0, so C will be 67 only. And D is also 67. Next, we come to this format specifier. So in the format specifier, we have three percentage D's and one percentage C. So percentage D means that whatever argument is given, you interpret it as an integer and you print it like a normal integer. So A, B, C, they are these values. So A is 103, B is 55, and C is 67. So
Sir,
10,
D is taking a sky value. We mean 67 is for C, a sky value for C.
no, no, it will be the case for D.
Yes, sir, for D.
D is asking value. So for the first three, 103, 55, and 67 will be printed. But for the last one, the format specifier is percentage %C. So percentage %C means that this last argument D, it will be interpreted as a character and it will be printed as a character. So 67 is the ASCII code for C, capital C. So capital C will be printed. Okay, so moving on to the next question. This is the next question. Okay, so in this question, basically you have to match the function call with the appropriate description of the function. So what will what will this function call do? What will that function call do? And all. So so as I said that seeking. So as I explained in that slide, seeking means that when you have a file, we normally read the file sequentially from the beginning to the end. We normally read it sequentially from the beginning to the end. But many times it might be required for us to rewind the pointer, or we might have to go to an arbitrary position in the file. Like say the data is located somewhere over here. Okay, so then why waste time reading the first half of the file? We can directly start from the second half. So for those use cases, this fseek function is there to move the file pointer to the appropriate location. So the call is pretty intuitive. We pass the file pointer, then we pass how many places to, like which position to go, and finally we pass the reference point. So like in reference to what, like the beginning of the file or the end of the file or the current position that we specify using this. So in this case the correct answer is D. Okay, so the first one, it matches with B. So the first one says that uh, so the first argument is same for all. So this one says that seek set and 10. So this corresponds to moving the file pointer forward from the beginning of the file by 10 positions. So position here means bytes. So seek set means that from the beginning of the file you move it 10 positions forward. The next one is 2C. So 2C means that here you can see -10 and seek cur. So this means that move the file pointer backwards from the current position by 10 positions. So wherever the file pointer is, you move it back by 10 positions. Next one is 3A. So 3A is 0 and seek end. So basically it is saying from the end of the file we move it 0 position. So basically move the file pointer to the end of the file. And the last one is -10 and seek end. So from the end of the file we move it 10 places backward. So like in short, this is the solution. So moving on to the third question. This is the third question. Okay, so Okay, so in this question, we have been told to find out that uh, what does this program do? So we have to describe the program. So here you can see that we have defined here so two file pointers, in file pointer and out file pointer, and in these two if blocks we are uh, opening both the files. Okay, so we are calling f open and the name of the file, f open and the name of the file. So one thing is that we are opening my file in read mode and we are opening proc file in write mode. Okay, then what we are doing is that we are reading a character using the fgetc command. So we are writing c equal to fgetc infp. Okay, and obviously like when we read a character we have to check whether it has been read properly or not, or is it null or not. So if the file if the file has already finished reading, okay, so it is towards the end, then this fgetc command will return an eof means end of file. So eof means end of file. So if the file pointer is towards the end, it will return eof, or else it will read the character. So so we are reading the character and then we are putting that character in out file pointer. So basically you can see that this is similar to copying a file. So we are reading the file byte by byte, I mean character by character, and character by character also means byte by byte. So we are reading the file byte by byte and we are writing it to some other file. So basically this will copy the file from myfile.txt to procfile.txt. But the but the but the twist is that here there is a if condition, and in the if condition we are checking whether the character is a space or a new line or not. And if it is a space or a new line, then you can see that this is a empty if block. So there is a semicolon here, which means that there is a empty if block. So if it is a new line or a space, then this f put c function is not called, which means that the new line and spaces won't be copied. So here therefore the answer will be C. It makes the exact copy of the contents from myfile.txt to procfile.txt without the spaces and new lines. And obviously at the end we are closing the files. Okay, so now moving on to the next question. So this is the next question. So in this question, we have to find the output of this piece of code. So it is fairly straightforward, but the thing is that here we are using stream manipulator functions to set various properties of the stream. Okay, so the first function is the std cout set f, and we are calling it with the argument is std ios show point. So this argument will basically manipulate the cout stream such that it always shows a decimal point. So if you have so normally what happens is that if you have a floating point number such as 11, and it does not have a decimal part, so it is 11.0 or something like 13.0. Then when you print this floating point number, it will only print 13 without the decimal, or 11 without the decimal. And same case for integers also. But when you give the show point argument, the decimal point will always be printed. Okay, so even if it is 0, this decimal will be printed, and the number of zeros will be according to the precision of the stream. So Cout has a default precision of 6 significant digits. Okay, so basically 6 digits, that is the minimum precision of Cout. So in this case, because of the show point, there will be 4 zeros that will be printed. Okay, 11 and 4 zeros. So total there will be 6 digits. So that will be the effect of this. Okay, in the next line what we are doing is we are calling std set fill 0 and std set w 0. Set w stands for set width.
So please explain again.
Yes, okay, explain. So uh, by default Cout has 6 significant digits of precision. Okay, so precision means the, you can think of it like this, that it is indirectly the number of decimal places. Okay, this is kind of like this, okay, but not exactly. So this is, instead this is actually the number of significant digits. Okay, so number of significant digits means that basically how many digits will be printed, minimum number of digits that will be printed. Okay, that is the precision. So in, if you have a number called, like if you have the number 1, then 1 and then 5 zeros will be printed. Okay, so 1 and 5 zeros will be printed, so this will be 6 digits. If you have 11, then 11 and then 4, so again it will be 6 digits. Okay, and if you have more than 6 digits, then the entire thing will be printed. Okay, but if you have less than 6 digits, then minimum of 6 digits will be printed. Next we have this std set width 10. So this means that we set the minimum width to 10. So 10 digits will have to be printed now. Okay, so here we have already printed 6. Wait a minute. Okay, so now set with 10 means that the entire string that is printed, that will be of 10 characters. So in this case, because of the show point, this 11.4 zeros will be printed. So that will be total of 7 characters because of the decimal point. Okay, 6 characters because of the numbers and 1 character because of the decimal point. So there will be 7 characters, and the remaining 3 characters, it will have to be filled with something else. Okay, because in this set width we have defined the minimum width to be 10, right? So the rest of the digits will have to be filled in somehow. So for that, the default character is space. Okay, so if we don't specify anything, uh, then what will happen is that 3 spaces will be printed, and then this 11.4 zeros will be printed. Okay, but here we have set the filling character to 0. So since the filling character is 0, so instead of 3 spaces, 3 zeros will be printed. Okay, so finally this will be the answer. So 3 zeros then 11, and then 4 zeros are after the point. So again, if I go over it, so then because of the show point, the decimal point will be printed, and after the decimal point, sufficient number of zeros will be printed so that the precision of the stream can be achieved. And the default precision is 6 digits. Okay, and since 11 itself has 2 digits, so 4 zeros will be printed. And this total string, it is of 7 characters, so the remaining 3 characters will be filled with zeros in the beginning. Okay, now moving on to the next question. So this is the next question. Okay, so in this question, we have to fill in the blank over here in line 1, such that the program prints the number of words in the file myfile.txt if the file exists. Otherwise, it prints unable to open the file. So, and another thing it's mentioned is that each word is separated by a single space. So you can go over this program. So in this program, we are opening a we are declaring an input stream with the argument as myfile.txt. So it opens the file. Then we have a character, and we are defining an integer. Then we are checking if the file is open or not. Okay, so if the file exists, then the file will get open, right? But if the file does not exist, then it will not open. So if it doesn't open, then it will directly come here and it will print unable to open file, which satisfies this condition. Okay, but in case the file is open, now we are going to read the file. Okay, so
Sir, what's the difference in if stream and is open?
if stream
Is open. if stream is also used for opening the file, and here we are checking my file dot is open for also checking the file.
No, if stream it opens the file, but the is open function returns that whether it is open successfully opened or not.
Okay.
So this is this line, the if stream line, this will attempt to open it, and this line it will check, or you can say verify whether it's open or not. Okay, so then we are reading in now in this block we are reading the file line by line. Okay, and wait one minute. Okay, so then here we are reading the file line by line, and here we are checking whether the I mean sorry. So we are not reading it line by line. We have to read it character by character. And because if we read it line by line, then we'll count the number of lines, right? But if we read it character by character, then we can check the number of words. So we are reading it character by character, and if the character is a space, then we are incrementing this integer. So this means that these two lines, it counts the number of words. So it says here that we have to count the number of words, and each word is separated by a single space. So this means that these two lines below, these count the number of words in the file. And after that is done, we are closing the file and we are printing this I variable to the console. Okay. So in this blank, we have to basically fill something which reads the file line by line. Okay. So over here, the two functions which satisfy it are B and D. Okay. So B and D, it will satisfy these functions. Okay. So my file dot get C, I mean my file dot get, it will return a byte, or see, byte and character, they are interchangeable. Okay. So byte and character, they're basically the same data type. So my file dot get will return a character. Okay. Or you can call my file dot get and you can pass C into the argument. Okay, it will do the same thing. So these two will work. And why will these two work? Because both of these are unformatted IO. Both of these are examples of unformatted IO. So they directly work on the byte stream. If this if it was formatted IO, then it would try to read the bytes and it will try to parse it in interpret it as a human readable format. Okay, now moving on to the next questions. So this is the next question. So this is based on these templates. Okay. Okay, now so in this question we are defining a templated function called min max. Okay, so why is this a templated function? Because before this function signature, we see the template keyword with two class names, itr and t. And in this function, you can see that this logic is there. So first we are defining min and max, and then we are basically we are so both we from these lines we can guess that this first and last. Okay, so first and last here they are probably pointers. Okay, they're probably pointers. Okay, so we are basically looping in this thing. We are looping over the whatever container is given. Okay, we are looping until the first becomes the last. Okay, at the end of the loop you can see this line plus plus first, which means that in this loop basically first pointer the first pointer it is incremented. Okay, so it is in it is incremented until it becomes the last. So if it becomes the last pointer, then you know that you have covered the array, right? You have traversed over the array. So that condition is there. Now inside the while loop, we are checking whether the like standard logic, we are checking whether the first is greater than max, then max becomes the dereferenced value of first, and then similarly for the minimum. Okay, so that is that. Now coming to the main function. In the main function, we have two variables called min and max. Then we have a integer array with these values, and then we are calling min max with this argument. Okay, so the first argument is IARR. So IARR will obviously point to the beginning of the array. So it will point to 5. Next, so the second argument is IARR plus this thing. Okay, so this whole thing, this basically returns the size of the array, or I should say with the number of elements in the array. The number of elements in the array. So this thing returns the number of elements in the array. So when you add it to the beginning of the array, so IARR is the beginning of the array, right? So when you add the number of elements to the beginning of the array, you will get a pointer at the end. Okay, so the first pointer will be over here and the last pointer will be over here, and then you also pass these variables min and max. Okay, so this is the way in which the function is called. So one thing you can see is that if this is the way the function is called, in the similar way the arguments will be written over here, right? So obviously this is first, this is last, and this is max, and this is min. So in the argument list, you will see that first the argument order is first, last, then max, then min. Another thing you will notice is that min and max will have the same data type, and this first and last will also have the same data type, because first and last are both pointers, and min and max will both be integers or like whatever. Okay, so they will be of the same data type. They may not necessarily be integers, but they will be of the same data type. So in this thing also you can see that in the options also you can see that min and max they have the same data type, and first and last they also have the same data type. Next, but one thing you have to keep note is that first, last, and min max they will be different. Okay, so first one is obviously a pointer, first and last they are obviously a pointer, and min and max they will obviously be integers. So I mean integers or something else. Okay, so they will not be pointers. So hence they cannot be of the same type. Okay, they will have to be different. And the other thing is that although this is integer here, okay, if we pass the integer directly to the function, let us say that we pass these integers directly to the function, then in the function you can see that it does not return anything, right? There is no return statement, which means the function has to modify the original min and max. Okay, this function min max, it has to modify this original min and max. So how will that be accomplished? It will be accomplished by passing a reference. So we have to call this function by call by reference, at least for the min and max values. So which means that the last two arguments they will have to be references. Okay, and in the last option you can see that they are of all of the same type. So this will not work obviously. Like the first and last they are pointers, whereas min and max they are objects, user defined objects or data types. So they will not be of the same type, they will be different. So this option is gone, and the first option is also gone because here there are here this min and max they are not references, they are the direct data types. So that leaves with B and C option. So both of these options are correct. Okay, now so then moving on to the next question. Okay, so in this function we are including all these header files, okay, and then we are defining a function called compute. So the compute function, it will take a list. So a list is a generic data structure from the STL library. So this will take a list of integers called li, and then it will compute some result from this list based on the accumulate function. So accumulate function, it is part of the so it is part of these like it is part of the I think it is part of the functional library. Okay, accumulate is part of the functional library, and it will return a result. And now in the main function, what we are doing is we are defining a integer array 10, 20, 30, 40, and we are calling this compute. Okay, so no, we are
Sir,
now,
so,
yes,
so generic data structure means it can take all the types.
no, we have to specify the type. Okay, but I mean that you can have list of integer if you write integer over here. You can also have list of double if you write double.
So then what is the difference in array and list?
Array and list. So array is a so list like I'm list. I think it is a linked list. Okay, whereas array is like a fixed array. Okay, fixed size array. In case of the which array are you talking about?
Sir, here in this question, it is given int array, and then in the next line it is given as list int. So both are working like the same way. I mean, here also in this list we are providing first pointer and end pointer. That means it is giving the whole array.
Wait a minute. Let me check. Okay, so basically, this list is a linked list. Okay, whereas array is a normal, it's a fixed size array. Okay, and like that in array it is stored. Array and linked list, they are stored very differently in memory. Like array is stored as a contiguous block of memory, whereas linked list it is stored like this. Okay, linked list is stored like in this manner. Okay, and when
Yes,
I say generic, I mean that it can be like it can be used for any data type.
yes, sir. But sir, in this question, it is also included a header file, hash include list. But for linked list, we do not use any header file. So I'm confused in array and list.
Okay, so in linked list, so see in linked list, if you are going to write it yourself, okay, then you don't need to include a header file. Okay, but uh, here we are using already defined like this list linked list. It is already defined in the standard library. So we are
Okay,
just
sir.
using that. Okay, so this is a inbuilt linked list.
Okay, sir.
Okay, as you know that you also have vector, right? You also have vector. So how do
Yes, sir.
you how do you use vector? We write hash include
So we
vector.
use header file, vector header file.
We write hash include vector, and then we can use vector in the same manner.
Yes, sir.
But the like all of this, they look very similar. Okay, but the difference is the underlying data structure and how is it stored.
Yes, sir.
So over here, so we have this array, and then over here we are basically converting the array to a list. So we are passing the beginning of the list and the end of, I mean the beginning of the array and the end of the array. So ARR will obviously point to the beginning, and ARR plus this, so this expression will give the size. So in this case, this expression will give us 4. So beginning and end, it will be passed to the list. It will be passed to the constructor of the list. So it will convert this array into a list. Then we are calling the compute function with this list. So the compute function, it takes a list and it calls the accumulate function on the list. So the accumulate function is also inbuilt function. Accumulate is also inbuilt function. So what does the accumulate function do? Suppose you have some data structure like this. Okay, suppose you have some array or list or vector. Okay, you have some data structure like this. So the accumulate function, it basically, it is kind of like a sum. Okay, it is kind of like a sum. So what it does is that, suppose you have this variable called s equal to 0, which is initialized as 0. Okay, so then what you do is that you add the first element here, then you add the second element here, then you add the third element here, then the fourth, then fifth, and then sixth. Okay, so you can see that this is kind kind of like accumulating all the array elements into one variable. Okay, so like if I repeat it again, so suppose you have an array like this, and let us say the accumulating function is summation. Okay, so if it is a summation function, then you add the first element to s, then you add the second, then third, fourth. Okay, so at the end you will get, at the end s will be the sum of all elements. So in a way, you can think that you are accumulating all the array elements into one number. So that is the, that is why this is called as accumulate function. So in the accumulate function, first, in the general accumulate function, what we do is that first we specify the, wait, let me erase this. So the general form of the accumulate function is this. We specify the first pointer and the last pointer. Okay, so this will give us basically the first, beginning and the end of the array where we have to operate. Then we pass the initial value. So here you can see that I've initialized s with 0, but I could have initialized it with something else also. Okay, then like let us say I initialized s with 10. Okay, and then I call this accumulate function. So it will give me the sum of all the elements plus 10, right? It will not give me the sum of all the elements because it is initialized as 10. So that option is also there. So we can specify the initial value of the variable, and then we can specify this function that has to be done. Okay, so if we want the sum of all the elements, then we use the addition function. Okay, if we want the product, then we use the multiplication function. If we want something else, okay, like let us say that we want some counting kind of function. Okay, uh, then what we can do is that we can just create a dummy function that returns +1 for all the elements. So so the last argument, it allows us to specify what operation that we have to do. So using this thing, okay, we can immediately say that so using this thing we can immediately say that the first argument will be list.begin and the last argument will be list.end. Okay, this will be same for all of the options. Okay, otherwise it will not work, right? And for the last argument, okay, now coming to the third argument, the initial argument. So if we wanted the product of all the variables, then the initial value would be 1. Why? Because see, so in case of sum, how does it work? In case of sum, finally s becomes, so s is initialized at something, let us say s init. So let us say s init is the initial value of the um, thing. So at the end of the accumulate call, it will be s init plus arr0 plus arr1 plus arr2, like this. Okay, now if we replace the addition with multiplication, then it will be like this. Okay, right, it will be like this. So if we want the product of all the elements, then s init must be 1. Okay, because like if s init is 0, then the product, like whatever the array we give, it will be 0, because then it will be 0 into everything. But if you want the product, then s init has to be 1. But in this problem, it says that the product has to be divided by 2, right? The product has to be divided by 2. So therefore the init function will be 0.5. Okay, init function will be 0.5. We still have two options here, multiplies double and multiplies int. So in this case, the correct option will be multiplies double. Why? Because here you can see that we are multiplying it with 0.5, which is a double value. Okay, so if we use multiplies int, then what will happen is that there might be some error in the computation. Okay, so suppose your array has odd values, okay, odd numbers. Let us say your array has 1 3 5, then the answer should be 15 by 2, which is 7.5. Okay, it should be 7.5. But if we use multiplies int, then this might not work. Okay, it will give 7. So for correct output, the we must use the double variant. Okay, so now moving on to the next question. This is the next question. Okay, so in this question is basically about this inner product function. Okay, so this again, this inner product function, it is part of the algorithm library. So inner product is actually another name for the dot product. You can, like, if you have studied physics, okay, you will know that in physics we have something called dot product. So dot product
Yes,
works. So dot product, we know it works like this, that first we multiply. If we have two vectors or two arrays or whatever of the same length, then what we do is that first we multiply the corresponding numbers like this, and then we add them. We add them like this to get the final answer. So this inner product is like inner product is actually another name for dot product only. So over here you can see that there are two operations involved. First is the multiplication and then is the addition. Okay, so for the addition one you can okay, wait. So the addition one, it is kind of like the accumulate function that we saw in the. Okay, so we know that in case of addition it is similar to the accumulate function. So this inner product function, it is like there is another operation in addition to accumulate. Okay, so in accumulate we have only one operation, but in inner product we have, firstly we have two lists or two arrays, and we have another operation which is multiplication. Okay, but we can change it. Instead of multiplication also we can give some other operation also. Okay, but we can change it. Okay, and finally we have the addition one, which is similar to the accumulate one. Okay, so here we are defining two functions, if you see. Okay, so uh, here we are defining two functions. So this operation 2, this is a normal function. Okay, it takes two arguments and it gives us the product. And this first one, this is what we call a functor. So a functor is something which is not a function. Okay, so uh, this is actually a struct. Okay, so this is not a function, but it overloads this call operator. Okay, so this call operator has been overloaded, so it can be used like a function. Okay, it can be used like a function. Okay, so this is the basic difference so between function and functor. So functor, it is like at its core it's not a function, but it can be used like a function because the call operator has been overloaded. So anyway, this function, it gives us the sum. Okay, now the inner product. So this inner product, it has this following function signature. First we give the uh, first we give the so the inner product, it operates on two arrays, right? So the first one will be first the first array's beginning and end. Okay, then we have the second array's beginning. Okay, and we don't need the second array's end. Why? Because in case of inner product, the size of both the arrays have to be same, right? We know this. So from the first array's beginning and end, we can deduce the size. Okay, so it must match with the second array's begin and second array's size. So that is why we do not explicitly need second array's end. Then we have the init value. Now what is this init value? The init value will be used here. So in this case, you can see that we are summing it, right? So wherever some summation is involved, we know that there is some initial value that has to be considered. So that initial value is specified as the fourth argument. And then we have the two operations, op1 and op2. So here, as I showed, that there are two operations involved. There is a multiplication and there is an addition. So those two operations, you can specify it as op1 and op2. Okay, so this is the function signature. Now the inner product's formula is this. Okay, so the formula is this. So what it means is that we take the ith elements from the first and the second arrays, and then we apply op2. Okay, so op2 is applied on the uh, ith element of the first and the second array, and then this thing is, and then op1 is applied on accumulator and this result. Okay, so from this you can see that op1 must be your plus operator. Okay, because it is applied to the accumulator and the result of this. Okay, and op2 has to be the multiplication operator. So first we multiply both the values, ith values, like this, and then we accumulate them. So therefore from here you can, and obviously since we want the, we can guess that init must be 0. Not guess, like it has to be like that. So, okay, so op1 is plus and op2 is into. Okay, and then these are the, like, first begin, first and second begin, these are standard things. Okay, so here you can see which is the correct one. So all are beginning like this, and li end is also same for all. Li2 begin is same for 3. So here you can exclude d because here is li2 dot end. Then the first element must be, then the first element must be 0, so you can exclude c. And over here between a and b, we know that operation 2 is a normal function. Okay, so this one will give us a syntax error. Okay, so we can exclude b. And in case of a, you can notice the difference here. So we are passing operation 2 by just the name, because operation 2 is a function. Okay, whereas in case of operation 1, Operation 1 is a functor. Okay, operation 1 is not a normal function. So here you can see that we are using this open and close braces to pass the function.
So, are we done with the questions?
Uh, Wait, the screen sharing is not working. Okay, now moving on to the next question. So this is the next question. So this is a pretty simple question. So this is a pretty simple question. So it mainly uses the std colon copy function. So this is again part of the algorithm header. Okay. So the copy function, it is basically used to copy one thing from, like it is used to copy one container to another container. Mm, okay, and the syntax is this. The syntax is also pretty simple. The syntax is first, last, and uh, result. Okay, so it copies from the first to the last into the result. Okay, that is the syntax. So like if you have a source, right? You have a source and you have a destination, and the source also has a first and it has a last. So it copies from the first and the last of the source into the destination. This destination you can also call it as the result. So here it says that identify the appropriate call to the copy function such that it prints the world as output. Okay, so in this function you can see that there is a character array called WRLD, and L is the number of elements here. So the L is equal to 5, and then we are creating a vector of characters, and in this line we are iterating over the vector. Okay, so from cvec begin to cvec n, and we are printing the contents of the vector. Okay, so the character array is not printed here, the vector is printed here. So it means that we will have to somehow copy the character array into the vector, and for copying we can use this std copy function. So obviously if we have to, so looking at the options we can see that which one is correct or not. So
So it's option C.
yes, option C is correct. Okay, but there is another option, correct option also. Okay, so there is another correct option also you can see. So obviously the option D is incorrect because
So,
option D is
sir,
incorrect.
option B is also correct because we are passing the address of first element and address of last element.
Yes, yes. So B is also correct. So option D is obviously incorrect because we are passing the destination first and then the source later on. And um, option A is also incorrect because arrays don't have a dot end function. So CRR is a normal character array and it does not have a dot end function. So there were the options at B and C. So okay, so that is it with the questions. Okay, so like that concludes today's class. Okay, so thank you for attending.
Thank you, sir.